In these problems, we are going to be tackling some really difficult looking derivatives using something called the chain rule. And again, there's another new type of notation here that you might not have seen before. This one says find big D sub x of y for the function y equals this mess. Well, that just means find the derivative with respect to x of y. So what is the chain rule? Well, the chain rule, I'm going to show it to you for the power rule situation, which is what we have here. We have a polynomial being raised to a power. What you do is you're going to substitute something in here. You're going to say that some value equals this chunk in the middle and then work on differentiating that value. So the way we do that, we say that the derivative of u to the n is n times u to the n minus 1, and that should look pretty familiar so far. That's just applying the power rule, times du dx. And how does that work in the context of a problem like this? Well, what you do is you take this inside chunk and you say that's what u is. So u equals 9x to the fourth plus 8x cubed. Now the other part in here, if we have u, we're good. This part is just the powers, but we have du dx. Well, that's the derivative of u with respect to x. So I have to find the derivative of this chunk. So I'm going to do that right now. And I can do that because I just have to apply the power rule. 4 times 9, that's 36. And then decrease the power by 1, I get x to the third, plus 3 times 8 is 24, x squared. So now I've got my u, and I've got my du dx. So I'm going to reset up this problem, y equals, and instead of this raised to the third power, I'm going to say that's u to the third power. Now that I could take the derivative of. Let me get this out of the way. So to do that, I simply say y prime here is going to be 3u squared. But because of the chain rule, I have to remember we have to multiply du dx. Now once I've gotten this far, all I have to do is substitute my u and du dx back in, and I'm done. So y prime here, or big D sub x of y, is 3 times, and I'll put u back in. U is 9x to the fourth plus 8x cubed, and that's quantity squared now, and times du dx, which is 36x cubed plus 24x squared. So that is how to use the chain rule to solve something like this. Let's try one more just like that. Same thing. We've got a quantity raised to a power here, a polynomial quantity raised to a power. So we're going to find, let's say, we're going to say u equals this stuff inside, so 7x to the fifth plus 6x squared. And we want to also find du dx, so we're ready to do this. So 5 times 7 is 35, x to the fourth plus 12x. Okay, so we've got our u and we've got our derivative of u. Now we set up our problem. y equals u to the fifth power. So I've just rewritten this with u substituted in. Now y prime equals, well, let's operate the power rule on this, so 5u to the fourth, but we have to multiply it by du dx. And now we can substitute our values back in. So y prime is 5 times, and u is 7x to the fifth plus 6x squared, and that's all to the fourth. And du dx is 35x to the fourth plus 12x. Let's look at one more. So this one looks pretty daunting to begin with, but I think the first thing I'd like to do is just rewrite this function. I'm going to call it y, and instead of a fifth root here, I'm going to say we raise this to the 1/5 power. Remember, when you have a root, that's the denominator in a fractional exponent. So now this looks like something we could do with the chain rule. So we'll call u this stuff inside. U equals 5x to the fourth minus 17. And let's find du dx while we're at it by taking the derivative of this. So that's 20x to the third, and that 17 just disappears, so that's fine. Now we can set up the problem like this. Y equals u to the 1/5 1/5. And we can use the power rule on this. So y prime equals 1/5 u, and then this is going to be to the negative 4/5 because I have to decrease that power by 1, and 1/5 minus 1 is negative 4/5. But because I use the chain rule, I have to remember to multiply by du dx. Now let's go ahead and substitute our values back in. So y prime equals 1/5 times 5x to the 4th minus 17, that's what we said u was, times du dx, oh wait, sorry, to the negative 4/5 times du dx, which is 20x to the 3rd. Now, this is a correct answer as we have it written here, but since the problem originally gave it in this form with a radical sign, I think we should put it back into that form. And if you look at this, we have a negative exponent, so this is actually going to be on the bottom of a fraction, this part. This part is on the bottom of the fraction. This is what would remain on the top of the fraction. So I can rewrite this as 20x to the 3rd on top. And on the bottom I get 5. And then this quantity is going to be a 5th root, but raised to the 4th power. So we'll take a 5th root of quantity 5x to the 4th minus 17 to the 4th power. So that's how to write that 4/5 power. So there is a little bit of work with the chain rule. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethisSchool.org. Thanks.